Okay, section 2.3 gets into building what are called postulates. It's going to give you several postulates and tell you what it means. Um, I don't expect you to memorize this, so remember that the reference page that's listed in the Get Started module contains all of these if you need to go back and look at them, or you can come back to this section. First is called the two-point postulate, meaning if there are 2 points, there can only be one line that goes through both points. And the line point postulate then states that a line has at least 2 points. It can actually have several more. The line intersection postulate says that if 2 lines intersect, they intersect at 1 point. Um, if you have 3 points that are on the same flat surface, they exist in one plane, is the 3-point postulate. And the plane point postulate says a plane contains at least 3 non-collinear points. However, if you do link 2 points together, you have the plane line postulate. If 2 points lie on a plane and they contain lines in the plane, so points D and E are on the line DE. The plane intersection postulate says that when 2 planes intersect each other, they intersect to form a line, and you can see that on the bottom. So going on, so the if then statement says if you have intersecting lines, then they intersect at a point. So the solution to that, if 2 lines intersect, then their intersection is exactly 1 point. Looking at the plane intersection postulate, if 2 planes intersect, their intersection is a line. So we're looking at an example here, and we look at the plane point postulate. Plane P contains at least 3 non-collinear points A, B, and C. You can see plane P identified down in the bottom right here, and then you can see the points A, B, and C are on that plane. And then the plane line postulate, point A and point B are on the same plane, so the line containing A and B also are on that plane, also is on that plane. So we're going to look at this one, sketch a diagram, and interpreting the diagram. So we're sketching a diagram, or a diagram, making a diagram that shows a line TV that intersects the line PQ. So you see the line TV going up and down, and then you see P and Q going across, and it's intersecting at a point W so that it's a midpoint, so that TW is equal or congruent to WV. So because we know that they're congruent, we can put that little red mark through it to show that. Okay, and then the last part shows perpendicular. A line that is perpendicular to the plane is also has to have the right angle symbols with it. So if we look at this diagram, can we say which of these are true? Can we say that A, B, and F are collinear? So we have A, B, and F on the vertical line. So yes, we can say that. Can we say that E, B, and D are collinear? since we do not have a line connecting them, we can't say that at this time. Alright, can we say that line AB is perpendicular to plane S? Here's plane S. There's line AB, and we see a right angle symbol. So yes, we can say that that is perpendicular. Can we say that line CD is perpendicular to plane T? Alright, so plane T is the vertical plane. We see the line CD there, but we don't see a right angle symbol. So no, we can't say that from this diagram. Finally, does the line AF intersect the line BC at point B? So AF, the vertical line, line BC, the horizontal line where the planes intersect, and that is only 1 point, so yes, we can say that because that's the point intersection postulate.